Hello, everybody. My name's Simon, and I'll be taking you through how to do asynchronous networking in JavaScript. I've prepared 5 lectures, the first of which goes through sort of some history, lays the groundwork for what we're going to be doing. And then the second lecture is all about sort of the underpinning mechanics of JavaScript's asynchronous model. And then the final 3 lectures will be all about the actual technical details of how we go and do asynchronous networking in JavaScript. So without any further ado, let's just dive straight into it, shall we? Okay, start this presentation. So asynchronous networking in JavaScript. The first thing that we're going to be talking about is the client-server model and what this phrase called AJAX is. Maybe you've heard of this phrase before, but if you haven't, then we will define it by the end of this lecture. Okay. Let me just make sure that my little window isn't covering things. All right, so a little bit of recap from 1531, or if you haven't done 1531 before, then this will be, I suppose, the first time you've heard of this, although I doubt it. So when we talk about client servers, this is an architectural pattern for how to do networking is one of the main examples. It also happens even when you do APIs. You have like client APIs or people who use your APIs, and then people who provide the services of the API are called servers. So client and server. And for our purposes, a client is a smartphone, it's a laptop, it's a computer, it's a web browser, it's something like this. And our servers, generally when we talk about servers, we're talking about racks of machines and data centers. And these data centers collectively are what we call the cloud. So these servers that are owned by Google, that are owned by Facebook, Amazon, all of their services run on these servers, which are locked away in data centers, frigid environments to keep electricity going. And the way it works is that our client, us, we make a request. So this user is on DuckDuckGo and they're trying to search for cats. They make a request to the server. The server is going to do some processing. This processing includes validation of arguments, executing some API, depending on what we're actually requesting. In this case, we're just going to be requesting the autocomplete options, and then the server returns some data back. And so you can see here in this DuckDuckGo window, the user has started to type in cats, and then the things that we get back are the autocomplete results from the server, and the server has determined that cats obviously is something that you might want to search for if you search for cats. And catsis is another potential autocomplete solution. And it's the job of the client to take this data, generally. The data at least will contain raw data like what you see here, but the server also can send back some HTML, it can send back CSS, and it can send back JavaScript scripts, which your browser goes and executes. And this is what we call the server response. So the request, right, is what we send to the server. And then the response is what we get back from the server. And I mean, this is how client servers work. Clients, they send things. I guess I'm in reverse, aren't I? Clients, they send things to the server for their whatever they need for like a request. And then the server sends back the response. And so it's this interplay that we call the client server architectural pattern. But it's not as simple as having one client and one server. No. What's more likely to be is that your app has multiple clients that are being deployed. Like you could have your mobile client, or you could have your desktop client. You could have your headless client, which is relatively useless for a web app since it's all about the visual, but hypothetically, you could have such a thing. And then your server is actually taking all of the requests from these different clients here and then sending back responses to them. But this is also a bit of a lie, because what's more likely to be the case is that we actually have multiple clients and they're sending multiple requests to multiple different servers for all different APIs. So I've called this reality squared, because if you think about it, the left side, or I guess the right side, this reversing view, I'm going to say what's left and right for me, I'm sorry. And then you can like flip it mentally in your mind. But this side are all of the different possible clients that can exist, right? And then the right side are all of the different servers that can exist. And if you think about it, this is kind of like a bipartite graph, because you can imagine in your mind that every web client could connect to every other server, and that would be an n squared situation here. So web app 1 is sending a request over to the latest news API, and so is a web app 2. They're both sending requests to the latest news API, and they're fetching back, I don't know, the latest news, whatever's trending, whatever's cool. But web app 2 is also fetching from the super cool cats API, because maybe for every news tidbit, they're also putting in a fact about a cat or an image about a cat. And so when we talk about client servers in the modern age, this is the reality, where servers are under intense load, but clients, they're not isolated, because they are also sending multiple requests to different servers, but the clients don't make as many as the servers do. But you can see we potentially have a problem, right? Because it's not as simple as having a one-to-one connection. We have some design considerations that we have to take into account. So what are these design considerations? Well, for a client, interactivity and responsiveness, which is low latency, right? That is the most important thing for a web client. We need to make sure that user input is serviced basically as soon as it happens, and that for any long running operations, the user needs to know the progress of what's happening. Obviously, you can do that in terms of like a spinner or a progress bar or some sort of loading screen. But the idea of responsiveness, even if your app is extremely slow, just it being responsive gives the perception that this app is very, very usable, right? The client side, ideally, the first time you load it should be really quick. And you only ever do an initial hard page load once. It's kind of interesting that as the internet bandwidth speed has gotten quicker, people have actually become less patient when it comes to loading pages. And if you think about it, that kind of makes sense, right? Because if everything loads fast, but then yours just happens to load really slowly, then that is out of the ordinary. But if everyone's used to things loading slowly, then it doesn't like stand out as much. And obviously, it only ideally wants to load once, because if we load the page multiple times, then you have the potential for like losing where you are in an anchor point, or if you don't have an anchor point, you'll lose your place because you'll just jump straight back to the top of the page. If you're like in the process of filling out a form, you'll lose any unsaved data. It's just really, really bad user experience that a page reload can make the person, your user, lose their flow or lose their place in where they are in the document. And if you're writing client-side code, naturally, everything that you do is client-focused. So we need to make sure that all of these things, these 3 points, are actually met. And this isn't a course about server-side architecture or how to write fast servers, but I think it's informative to at least know kind of the concerns of the server, because you really want to know how to like work in tandem, since the server does support you. And server side, what happens is that servers need to handle thousands of requests every second. Thousands of requests come in. And you want each of these requests ideally to be handled within single-digit millisecond response times. Servers, where's my mouse pointer going? I can't see it. There it is. Servers also deal quite heavily with resources. So resources, not just time, but hard resources like power usage, the number of servers. There's obviously the amount of time it actually takes to do something. But these data centers that host the servers, incredibly expensive to run. Every microsecond, every millisecond costs real money that we need to minimize. Not only that, it's also an environmental thing. The better your servers operate and the more performant that they are, the less power that they use, which obviously is good for the planet. So I think trying to write good code, fast code, minimal code is all around a good thing to understand. Maximizing throughput, right? That is I've lost my mouse pointer again, keeps disappearing. Maximizing throughput is the most important. Actually, let me see, I think you can actually turn on a laser pointer. Is that, What is that? Is that this? Yes, haha, now you can see the laser pointer. Awesome. Right, so maximizing throughput, that is the most important thing for a web server. Minimizing latency, that's the most important thing for your client. So these are the problems. We do have solutions, but to see how we got to those solutions, let's just take a brief little walk through history. So years ago, back in the era that I was born, the 1990s, what was the world like? And the early 2000s as well. Well, for one, there were no smartphones, that's for sure. Clients were majority desktop web browsers. I kind of lump laptops in with desktops because most of the laptops at the time just ran a very similar version of Windows 95, 98, 2000. So they kind of count as desktops. Most of the servers did not exist in the cloud. Google, I think, had just started by that point, and Amazon as well. So there was no GCP, Google Cloud Platform. There was no Amazon Web Services. None of this. If you ran a web-based business, you had your own servers on your premises somewhere. This is by far the era of the static web page, right? Static web pages, that is that, you download, you send a request to a web server, it downloads the HTML, the CSS, very minimal JavaScript because CPUs were very slow back then. And then it renders once and then that's it. Anytime you wanted something to change, you would have to send another request and get back a new HTML page from the server. And that's called, well, that technique is called server-side rendering, but you can think about it as a static website. So every web page is literally a separate HTML page, which is not by far not the case nowadays. And the way you would scale your web app is that you would upgrade your server because the server does everything. It handles rendering of the web page, it handles the actual business logic, it handles database access, it handles everything. So if you need a better web app, like one that's faster, one that can handle more requests, then you have to get better hardware. And that was basically the case throughout the 90s, early 2000s. The internet, you have to remember that the internet was only born just, I think 93 was when the World Wide Web Consortium was founded. So yeah, people were just starting to figure out everything, right? And then we come to the mid-2000s, like early 2000s, mid-2000s, basically what do we call that, the noughties, right? The majority of clients, they're still basically web browsers, but JavaScript is getting more, it's getting used more and more, in no small part because of jQuery, which is I think the most widely used JavaScript library around. And CPUs are getting faster. Still, like we're getting into 1, 2, 3 gigahertz range. I think 2 gigahertz by like 2007 was quite common. More RAM, obviously. But we're still kind of just trying to take whatever is happening in this side in the 90s, just kind of to its logical conclusion. There's not really any big architectural changes. We're still scaling the servers vertically, but we are starting to see a lot more horizontal scaling. But the biggest thing that happened for web by far is the iPhone and smartphones in general, because for the first time in technological history, computer science history, your web clients were no longer your, like, how would you say, classical computer. For the first time, we have a handheld computer that is almost as powerful, at least in terms of rendering web pages, as the computers of the 90s. In fact, I'm sure the iPhone was stronger than the gateway PCs or the Hewlett-Packard Bell machines of the 90s. These are old computers. Maybe you guys don't know the brands, but basically the smartphone changed everything, right? Because now, especially going through the 2010s, 2011, 2012, definitely when AWS launched, GCP launched, like most clients of web things now aren't computers. They're Internet of Things and mobile clients. So Internet of Things is things like, well, anything that has internet connectivity, smartphones, obviously, computers still, they're the classic examples, but what's the word? Fridges, washing machines, because apparently that needs to be a thing. Raspberry Pis, web cameras, all of these can connect to the internet. And if they have a display, it's almost incredibly likely that the display that they're using is probably a web browser-based display. And that is a thing that you can do. You can take like the rendering API of, say, Chrome or Firefox. I think it's called Gecko in Firefox or whatever, but you can embed it into applications. And that's actually how VS Code runs its UI. But the main point is, right, is that almost all rendering is client side now, and cloud server hosting is dominant. So if you want to make your web app, all you need to do, go sign up for, say, AWS, write your front end in JavaScript or TypeScript, which is typed JavaScript. And then you basically write a very simple backend that connects to your relational database like MySQL or something like this. You put your backend on the, say, EC2 instances on AWS, and then you just add like 5 of those, and AWS handles all of that, hard stuff for you. And then you just have it serve out the front end for you. And just like that, you have almost as much power as, say, Optus in the 90s when they were trying to create all their on-site servers. So things really did change when we came to the right side. So as you can see, some of the solutions of like minimizing latency, pushing server, what would you say, increasing server computational capacity through horizontal scaling, these already are some of the solutions. But let's take a look-see at what the sort of canonical things that we should say are. So on the client side right now, because most of the rendering is done on the client side, we have this nice separation of modularity. The client side, for all intents and purposes, really is the presentation layer. And then your server is just the backend logic and data layer. So we can leave the presentation strictly to the front end, which is good because it means that the front end can do things that we can optimize the front end for presentation, for responsivity, things like this. The next thing that we have been able to accomplish is that on the client side, the first page load can happen really quick because now with CPUs being so much faster and web browsers being very much more complex, what it means is that we can just grab the minimal amount of HTML, CSS, and JavaScript, stick it inside of the initial page load. And then for any other data that we need thereafter, we can grab it asynchronously. And this is a technique called lazy loading, if you're interested. But the idea is that we grab the minimal necessary amount of stuff first, and then after that, when the web app is running, as users go to whatever page that they need to, we grab the data there and then only. We don't grab everything up front, and this greatly reduces latency, which is great to see. Again, we're not looking at server-side architecture, but it's interesting nonetheless to see how servers do it. But server-side, right, they scale horizontally. So just in case you guys didn't catch the terminology, vertically is when you just add more hardware to a single server, but scaling horizontally is when you add more servers. So now servers, right, they've scaled to millions of requests per second because they also do asynchronous event processing, which is pretty awesome. And what this means in essence is that whilst we're waiting for IO, because backend servers also do a lot of IO, like reading from disk, grabbing information from networks, things like this, then they can go and serve other requests. So we're always moving, always moving. And of course, there is load balancing because we have many more servers. We have to figure out which request goes where. And that's called load balancing. So just as a recap, if we go back to the history slide, we started off everything being all together, or rather all together or on the server. Server does everything. Client side basically is a dumb renderer. It just grabs the stuff from the server and then sticks it on your web page, and the server handles all the complexity. In mid-2000s, early 2010s, mainly mid-2000s, I would say. Kind of the same, but we're starting to see some of these technologies evolve. And then in our present era, we have very much this nice separation of responsibility, and we're grabbing things lazily. And lazy loading is king when we're talking about responsivity, because what it means is that we can put all of our computational power on the responsiveness for the client, which is what we want. And the server handles its data fetching business logic asynchronously as well. So this idea of using asynchronous methodology to increase responsiveness, to reduce latency, to maximize throughput, this is what we call AJAX. And AJAX, the acronym, is Asynchronous JavaScript and XML. The XML was because before JSON became a really big thing, XML was sort of the, what would you call, language du jour of passing information across different services. But I think most people agree that XML is not used very much nowadays, but I don't think AJAX kind of rolls off the tongue as well as AJAX does. So take it for what you will. Maybe if we stop using JSON and we use YAML, maybe this will be AJ, and we'll get back to having a nice acronym. But we have to understand that AJAX is not a single technology. It is instead a set of techniques to create asynchronous web apps. Yeah. And the nice thing about AJAX, like I said before, is that it allows for, well, the smooth UI UX. It allows for a modular front end and back end, which is great. But even more, what it means is that we can also use offline apps, right? Because as the front end is changing, we're able to save the state locally and asynchronously push it to the server once we regain connectivity again. And that's actually how things like the whole Google Office suite works, and Office 365, like Microsoft's offering, they all work. If you like turn off your internet connection, pull the cable or whatever, turn off your Wi-Fi, then you'll notice that you can still use it. And then when you get connectivity again, then you'll realize that it will sync to the server. So that's pretty cool. And this diagram kind of represents sort of the old way, where the web browser is kind of just the interface. We send requests to the web server, it does its thing, and then the web server sends back everything. But now the web browser still has a user interface, but we're pushing through to this hypothetical AJAX engine, which doesn't really exist, right? This is like the specific technology that we use to do all this asynchronous stuff. But you can think of it like we send calls off to this asynchronous engine, it does stuff, this asynchronous engine will eventually return, right? It's not synchronous, doesn't happen in a nice flow. It's like we're waiting for the results to come back, which we'll see coming up. But it's very much this closed loop, and then the web browser does its closed loop, which is pretty cool, right? So this is AJAX. And the client-server model, like the reason why I wanted to introduce this first is because we have to understand when we're talking about what we're going to be talking about, which will be XML, HTTP request, and then fetch and async await. These like three different things, right? They are all just a means to an end. They're just a means to go ahead and enable having a smooth UI UX, modular front and back end, offline app capabilities, all this stuff, right? So we had to like lay the groundwork. In summary, today, we talked about the client server model, and we gave a definition for AJAX. And next, we'll be looking at JavaScript. And how does JavaScript handle concurrency? What is concurrency? We don't assume that you guys have ever looked at anything to do with concurrency for, again, all intents and purposes. Maybe you've just only done synchronous programming up till now, but the world is much more exotic than just calling a function, waiting for the function to return, and then continuing. So that's what we're going to be talking about next. All right, I'll see you guys then.